Hi, this is Mrs. Solano, and today I'm going to analyze this pattern and determine what relationships exist. Okay, so in this problem here, they're asking us to find the perimeter of each figure, and we already know that the perimeter is measuring the distance around an object, so I went ahead and I labeled, as it said per the directions, the longest sides to be 2 and all other sides 1, that they measure 1 unit, and I did this for each figure so I could go ahead and fill out my table. So for figure 1, when I measure the perimeter, it's 8 units. For figure 2, 11, figure 3, 14, and for figure 4, it is going to be 17 units. So I went ahead and also put perimeter right there. Next, on question 3, it's saying graph the ordered pairs from the table on the coordinate plane. So I went ahead and graphed my figure numbers and the perimeter. So for this one here, and I also put here figure number because it says here X is the figure number and perimeter is Y, and I went ahead and labeled perimeter. So I went ahead and labeled that, and I put my axis down. So here's my x-axis, here's my y-axis. And I also noted that this here is the origin, 0, 0. So as I put the ordered pairs on my coordinate grid, I went ahead and put that the figure 1 was 8 units, so figure 1, 8 units, figure 2, 11, figure 3, 14 units, and figure 4, 17 units. So I went ahead and put that down. Okay, now looking at question 4, it's saying here, is the relationship proportional or multiplicative? Okay, so we already know that proportional and multiplicative mean the same thing. They are straight lines that go through the origin. Okay, and then it's also asking, or is it additive? Now, additive is a straight line, but it does not go through the origin. Okay, so if we look back here at our graph, we see that this here is going to be a straight line, but it does not go through the origin. I can verify that if I go ahead and use my ruler. Here I get a straight line, but it does not go through the origin. Okay. So therefore, because it's a straight line, but it does not go through the origin, this here is an additive relationship. So I went ahead and put on the graph, the line is a straight line that does not go through the origin. Therefore, the relationship is additive. Okay, so the next question it's asking is there a constant rate of change? How do you know? Okay, so in order to determine the rate of change, what's this at the bottom? Rate of change is always delta y, or the change in y, over delta x, the change in x. Okay, so this is really important in determining rate of change. But in order to find the rate of change, I have to look outside the table. So I have to find the change in the values outside the table. So this here is y, so I'm going to say delta y. And the change in y, to go from 8 to 11, I add 3. From 11 to 14, I add 3. From 14 to 17, I add 3. Then I have here delta x, or the change in x values. To go from 1 to 2, I add 1. From 2 to 3, I add 1. From 3 to 4, I add 1. Okay? So now, in order to see if there's a constant rate of change, I need to go ahead and do delta y over delta x. So now I'm looking at the values outside the table, and I have to do that for each row in order to determine if there's a constant rate of change. Now this one's pretty easy because these are all 3 over 1, 3 over 1, 3 over 1. And when I simplify those values, 3 divided by 1, I get 3. So I get here that the delta y over delta x is 3 for each row. Now if I get the same value, the same numerical value, therefore I know that there is a constant rate of change. So looking back over here, is there a constant rate of change? How do you know? Well, there is a constant rate of change because delta y, or the change in y, over delta x, the change in x, is the same value for each row. Okay, so that's how we determine the constant rate of change from a table. Now that we've done this example, I need you to go ahead and do this next example that is on the left side of your IS, and go ahead and complete all 5 parts, and we will discuss this in class. Thank you for your time.